Lecture 5 of the Fairyland of Science. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Fairyland of Science by Arabella Buckley. Lecture 5. The Two Great Sculptors, Water and Ice. In our last lecture, we saw that water can exist in three forms. First, as an invisible vapor. Second, as liquid water. Third, as solid snow and ice. Today we are going to take the two last of these forms, water and ice, and speak of them as sculptors. To understand why they deserve this name, we must first consider what the work of a sculptor is. If you go into a statuary yard, you will find there large blocks of granite, marble, and other kinds of stone, hewn roughly into different shapes. But if you pass into the studio, where the sculptor himself is at work, you will find beautiful statues, more or less finished. And you will see that out of rough blocks of stone he has been able to cut images which look like living forms. You can even see by their faces whether they are intended to be sad, or thoughtful, or gay, and by their attitude whether they are writhing in pain, or dancing with joy, or resting peacefully. How has all this history been worked out from the shapeless stone? It has been done by a sculptor's chisel. A piece chipped off here, a wrinkle cut there. A smooth surface rounded off in another place so as to give a gentle curve. All these touches gradually shaped the figure and molded out of the rough stone, first into a rude shape and afterwards, by delicate strokes, into the form of a living being. Now just in the same way as the wrinkles and curves of a statue are cut by the sculptor's chisel, so the hills and valleys, the steep slopes and gentle curves on the face of our earth, giving it all its beauty, and the varied landscapes we love so well, have been cut out by water and ice passing over them. It is true that some of the greater wrinkles of the earth, the lofty mountains, and the high masses of land which rise above the sea, have been caused by earthquakes and the shrinking of the earth. We shall not speak of these today, but put them aside as belonging to the rough work of the statuary yard. But when once these large masses are put ready for water to work upon, then all the rest of the rugged wrinkles and gentle slopes which make the country so beautiful are due to water and ice, and for this reason I have called them sculptors. Go for a walk in the country, or notice the landscape as you travel on a railway journey. You pass by hills and through valleys, through narrow steep gorges cut in hard rock, or through wild ravines up the sides of which you can hardly scramble. Then you come to grassy slopes and to smooth plains across which you can look for miles without seeing a hill. Or when you arrive at the seashore, you clamber into caves and grottos, and along dark narrow passages leading from one bay to another. All these, hills, valleys, gorges, ravines, slopes, plains, caves, grottos, and rocky shores, have been cut out by the water. Day by day, and year by year, while everything seems to us to remain the same, this industrious sculptor is chipping away, a few grains here, a corner there, a large mass in another place, till he gives to the country its own peculiar scenery, just as the human sculptor gives expression to his statue. Our work today will consist in trying to form some idea of the way in which water thus carves out the surface of the earth, and we will begin by seeing how much can be done by our friends the raindrops before they become running streams. Everyone must have noticed that whenever rain falls on soft ground, it makes small round holes in which it collects, and then it sinks into the ground, forcing its way between the grains of earth. But you would hardly think that the beautiful pillars in Figure 24 have been made entirely in this way, by rain beating upon and soaking into the ground. Where these pillars stand there was once a solid mass of clay and stones, into which the raindrops crept, loosening the earthly particles, and then when the sun dried the earth again, cracks were formed, so that the next shower loosened it still more, and carried some of the mud down into the valley below. But here and there large stones were buried in the clay, and where this happened the rain could not penetrate, and the stones became the tops of tall pillars of clay, washed into shape by the rain beating on its sides, but escaping the general destruction of the rest of the mud. In this way the whole valley has been carved out into fine pillars, some still having capping stones, while others have lost them, and these last will soon be washed away. We have no such valleys of earth pillars here in England, but you may sometimes see tiny pillars under bridges, where the drippings have washed away the earth between the pebbles, and such small examples which you can observe for yourselves are quite as instructive as the more important ones. Another way in which rain changes the surface of the earth is by sinking down through loose soil from the top of a cliff to a depth of many feet till it comes to solid rock, and then lying spread out over a wide space. Here it makes a kind of watery mud, which is a very unsafe foundation for the hill of earth above it, and so, after a time, the whole mass slips down and becomes a fresh piece of land at the foot of the cliff. If you have ever been at the Isle of Wight, you will have seen an undulating strip of ground called the Undercliff at Ventnor and other places, stretching along the sea below the high cliffs. This land was once at the top of the cliff, and came down by succession of landslips such as we have been describing. A very great landslip of this kind happened in the memory of living people at Lyme Regis in Dorsetshire in the year 1839. You will easily see how in forming earth pillars and causing landslips, rain changes the face of the country. But these are only rare effects of water. It is when the rain collects in brooks and forms rivers that it is most busy in sculpturing the land. Look out some day into the road or the garden where the ground slopes a little, and watch what happens during a shower of rain. First the raindrops run together in every little hollow of the ground. Then the water begins to flow along any ruts or channels it can find, lying here and there in pools, but always making its way gradually down the slope. Meanwhile, from other parts of the ground little rills are coming, and these meet in some larger ruts where the ground is lowest, making one great stream, which at last empties itself into the gutter or an area, or finds its way down some grading. Now just this, which we can watch whenever a heavy shower of rain comes down on the road, happens also all over the world. Up in the mountains, where there is always a great deal of rain, little rills gather and fall over the mountainsides, meeting in some stream below. Then, as this stream flows on, it is fed by many runnels of water, which come from all parts of the country, trickling along ruts, and flowing in small brooks and rivulets down the gentle slope of the land till they reach the big stream, which at last is important enough to be called a river. Sometimes this river comes to a large hollow in the land, and there the water gathers and forms a lake. But still at the lower end of this lake out it comes again, forming a new river, and growing by receiving fresh streams until at last it reaches the sea. The River Thames, which you all know, and whose course you will find clearly described in Mr. Huxley's Physiography, drains in this way no less than 1/7 of the whole of England. All the rain which falls in Berkshire, Oxfordshire, Middlesex, Herefordshire, Surrey, the north of Wiltshire and northwest of Kent, the south of Buckinghamshire and of Gloucestershire, finds its way into the Thames, making an area of 6,160 square miles, over which every rivulet and brook trickle down to the one great river, which bears them to the ocean. And so with every other area of land in the world, there is some one channel towards which the ground on all sides slopes gently down, and into this channel all the water will run on its way to the sea. But what has this to do with sculpture or cutting out of valleys? If you will only take a glass of water out of any river, and let it stand for some hours, you will soon answer this question for yourself. For you will find that even from river water which looks quite clear, a thin layer of mud will fall to the bottom of the glass, and if you take the water when the river is swollen and muddy, you will get quite a thick deposit. This shows that the brooks, the streams, and the rivers wash away the land as they flow over it, and carry it from the mountains down to the valleys, and from the valleys away out into the sea. But besides earthly matter, which we can see, there is much matter dissolved in the water of rivers, as we mentioned in the last lecture, and this we cannot see. If you use water which comes out of a chalk country, you will find that after a time the kettle in which you have been in the habit of boiling this water has a hard crust on its bottom and sides, and this crust is made of chalk or carbonate of lime, which the water took out of the rocks when it was passing through them. Professor Bischoff has calculated that the river Rhine carries past Bonn every year enough carbonate of lime dissolved in its water to make 332,000 million oyster shells, and if all these shells were built into a cube, it would measure 560 feet. Imagine to yourselves the whole of St. Paul's churchyard filled with oyster shells, built up in a large square till they reached half as high again as the top of the cathedral. Then you will have some idea of the amount of chalk carried invisibly past Bonn in the water of the Rhine every year. Since all this matter, whether brought down as mud or dissolved, comes from one part of the land to be carried elsewhere or out to sea, it is clear that some gaps and hollows must be left in the places from which it is taken. Let us see how these gaps are made. Have you ever clambered up the